Hi guys, and welcome to your last installment of your Chapter 5 notes. Today we're going to look at periodic properties. Of course, periodic meaning repeating, so we're going to look at those properties that repeat as we go through the periodic table. The first property we're going to look at is atomic radius. This is defined as the distance from the center of the nucleus to the outermost electron. Some books will describe this as half the distance between the nuclei of adjacent atoms. And so that's more when we're looking at elements that are being combined together to make compounds. So it's just like any radius, from the center of the circle to the outer edge of the circle. Same thing here, we're just looking more 3D. So from the center of the nucleus to its outermost electron. What we find in the property is that it's going to decrease as we move across a period. Now you say, well, that's weird. Why would it get smaller if we're adding electrons? Well, the reason it gets smaller is because there's an increase in positive charge in the nucleus. So it's not just that we're adding electrons to the atom, but we have to remember that we're changing our element, so we're changing the number of protons we have. So as we increase that positive charge, it's going to pull in on those electrons just a little bit more each time. So we're putting one for one, it's just pulling them closer. So as we increase positive charge, we're going to then decrease our radius. However, as we move down a group, we are going to increase. So I know you're going to say, but didn't you just say if we increase positive charge, we're going to decrease in radius? Well, this is because we are now moving to a whole new energy level. So we're not looking at within the same distance from the nucleus. We are now looking at being a whole nother shell, a whole nother level away from the nucleus. So of course you add another layer to the atom, you're going to get further from the nucleus. So it makes sense then that as we go down the group and we add more energy levels and we get further from the nucleus, it is going to increase. Ionization energy. Well, you go, what is ionization? Well, this is the energy required to remove an electron. So we have all these electrons, and we've talked about quantums moving electrons, but this is not just moving an electron to an excited state, but it's actually removing it from the atom itself. Most likely we're going to use it when we start bonding, so we're going to move that electron to another atom so that we can kind of form this bond between positive and negative. But we'll get into that in Chapter 6. So this, we just need to know ionization energy, energy required to remove an electron. When we remove an electron, we make an ion. So this is any atom or compound that would have a positive or negative charge we are going to call an ion. Doesn't matter which one for our purposes here right now. So ionization is just the process that results in the formation of an ion. So removing that electron, we're going to form an ion. So the trend is that as we move across a period, we are going to increase. So it's going to require more and more energy to remove an electron. So if you think about it, we are getting closer and closer and closer to the noble gases as we move across a period. Noble gases are pretty unreactive because they are full. So everything really wants to be like a noble gas. They would love to be full and not have to react and just be very stable. So as you move closer, you're adding electrons, you're filling up those orbitals. It really doesn't want to get rid of them as you get closer to a noble gas. Where something in the S block, now it's only got 2 electrons, so it goes, please get rid of them. If you get rid of these 2 electrons or 1 electron, I am going to be just like the noble gas. So it's going to be a lot easier to remove them in the S block. and then it's going to decrease as you move down a group. So the further away you get from the nucleus, the easier it is going to be to get rid of an electron. The next periodic property is electronegativity. And this is the ability of an atom to attract electrons. So basically the exact opposite of what we were just looking at. Ionization energy is the ability or the energy needed to remove. This is how easy it's going to be to attract an electron. So this is going to increase as we move across a period. So you go, well, if it's the opposite idea, then why does it have the same trend? Well, you got to think of the wording. In ionization energy, it's the energy to remove. So it's going to take more to remove as you get closer to the noble gases. Where in electronegativity, it's the ability to attract. So as you get closer to a noble gas, to get to be like a noble gas, it's going to be easier to gain a couple electrons. So it too is going to increase as you move across a period. And then as you move down the group, again, you're getting further from the nucleus, so it's not going to want to put electrons there. It's going to want to give them away easier than it's going to be to put them onto the atom. So the ability is going to decrease the further you get away. Then we have electron affinity. This is just the energy change that occurs when a neutral atom does gain an electron. So electronegativity is that ability to gain. This is the energy change that occurs when it actually happens. Now it does have a general kind of trend, but we're going to see that the trend kind of jumps a lot more than the other two. So I didn't put one down here. So we're not going to really look at the trend. We just have to know that there is a general trend when it comes to electron affinity, and it is going to follow along the lines of the electronegativity just because the idea is similar. And finally we have the Ionic Radius. Remember we just talked about ions with ionization energy? Well, when we build ions, we can have cations, which are positive, or we can have anions, which are negative. So when we build a cation or a positive ion, what have we done to get it positive? We have lost an electron. If we lose an electron, we're going to see a decrease in the radius because now your positive charge is greater and it's going to have a greater pull on the remaining electrons. Where the anion, that is a negative ion, it means we now have more negative or more electrons, so we are going to increase our radius. So our electron charge does outdo the proton charge, and we're going to add to it, so we're going to increase the radius. So here's just a general periodic table, and what are the trends? Well, as we move in this direction, we're going to increase our atomic radius. So that means these elements down here are the largest, and up here are the smallest. So it means that we increase as we go down, and we decrease as we go across for atomic radius. All of our other ones then are in the opposite direction. So in the opposite direction, we have increasing electronegativity, and like I said, electron affinity, and increasing ionization energy. So in that case, these would have the largest electronegativities, ionization energies, and electron affinities. Down here would be the smallest. So smallest. So what does this do? As you go down, it does exactly the opposite. It decreases, and as you go across, it increases. So that's kind of how to look at this. And that's why the arrows are more at an angle as you look at your periodic trends.